Hello everyone, welcome to the very first lesson of Algebra 1. And if you don't know, if you haven't watched my introduction video, the welcome video, I'm going to cover Common Core Math, and in Common Core I will start with Algebra 1. Once Algebra 1 is done, then I will start with Algebra 2, then I'll do Precalculus, then I'll also do CBSE Math. And today I am going to do Introduction to Radicals and what are rational exponents. This is the very first topic that you'll be doing in Algebra 1. So let's begin. All right. So there are two things. One is radicals and second is rational exponents. Now see, you are going to hear this word rational a lot. You're going to hear this word a lot, trust me. Now, you must have heard of this rational in grade 8 when you do rational numbers for the first time, right? So I'm going to write rational numbers. Rational numbers are those numbers which can be written in the form of P over Q. Okay, for example, you have 1 over 2, negative 3 over 4. These are your rational numbers. Also, you have your rational numbers as integers, 2, 5. They are also rational numbers because they can be written as 2 over 1, 5 over 1, and so on. The only condition is that Q cannot be equal to 0. Q cannot be equal to 0. Okay. Now, if I talk about rational exponents, what are rational exponents? Rational exponents. Well, these are nothing but exponents, but now they are in the form of rational numbers. That means you can have fractional exponents as well. And in grade 8, you did normal exponents, where your exponents were just in the form of integers, like 2 raised to 3, which is 8. And let's say you also did 4 raised to negative 2, which is equal to 1 over 4 raised to 2. So this exponent 3 and this negative 2, this is integer. This is not in the form of fraction, right? This exponent that you see, this exponent that you see, these are not in the form of fractions. Now, in rational exponents, we'll do something which is called, now you'll see the exponents will be in the form of rational numbers or in the form of fractions. So for instance, if I write 16 raised to 1 over 2. What? 1 over 2. 1 over 2 is a fraction now. How will you find the value of this number? What about 27 raised to 1 over 3? So these are nothing but rational exponents. So it just means that the exponents are in the form of rational numbers. It can be fraction as well. Okay, so this is nothing but rational exponents. Very soon we'll see how to evaluate this and how to evaluate this. Just bear with me. Now I also want to tell you what are radicals. Okay, what are radicals? First, let's just understand what are radicals. So in your grade 8, and I don't know, maybe in grade 7 as well, you must have heard of the term root. So you must have heard of something called square root and cube roots, right? You have heard of these terms. And how do we represent a square root? So if I want to find out square root of 16, I write it like this. This means square root of 16. If I want to write cube root of 27, I will write it like this. This little 3 represents that we are finding cube root of 27. What about fourth root? Let's say I'm writing, this represents fourth root, okay? Fifth root, this represents fifth root of 32. Okay, now these radicals are nothing but your roots. Yes, you heard me right, radicals are nothing but your roots. And there is one way of representing these roots. There is one way of representing these roots in terms of exponents. Did you hear what I just said? I can write these roots in form of these exponents. So see now, this is a square root. This can be written as 16 raised to exponent 1 over 2. This 27 can be written as, this is cube root, this can be written as 27 raised to 1 over 3. This can be written as 64 raised to 1 over 4. This 32 can be written as 32 raised to 1 over 5. So these are your rational exponents, and they're also called radicals. Okay, now let's see that how you can evaluate these numbers. Let's see. What will be the value of 16 raised to 1/2 power? That just means you want to find out a number. I'm just writing it like this, 16 square root. You want to find out a number which when multiplied by itself gives you 16. And that number is 4. 4 times 4 is 16. So square root of 16 is 4. Now, what about cube root of 27? Cube root of 27. So you want to find out a number which you multiply by itself 3 times. So you get 27. This is sort of like a riddle, right? So you know that if you multiply 3 times, so we get 27. So cube root of 27 is 3. Yes, as simple as that. Okay. What about cube root of 64? Let's make it 1 over 3. Cube root of 64. Which number? Pause this video and find out which number when multiplied by itself gives you 64. That's nothing but 4. 4 times 4 times 4 will give you 64. So the answer is 4. Then what about 32 raised to 1 over 5? That means fifth root of 32. So which number multiplied by itself 5 times will give you 32? That's 2, my dear. 2 times 2 times 2 times 2 times 2 is 32. So this is how you will evaluate these numbers. Now, don't worry, this was just an introduction. See, if you try to do it by this method, then you will require some hit and trial. You will need to think that, okay, which number should I think, which multiplied by itself 5 times will give me 32. So that will take you some time. Okay, there is a foolproof method as well. What is that foolproof method? We'll see now. Okay. Let's say you want to find out what is 81 raised to exponent 1 over 3. Okay, this means that this is cube root of 81, right? Okay. One thing that I want to tell you, it's just a general form. If you have a raised to 1 over n, this can be written as a and a small n over here. This is read as nth root, nth root of a. This is read as nth root of a. Now, if you want to find out the value of, let's change the color. Okay. You want to find out the value of cube root of 81. So the very first thing that you will do is you will find the prime factorization of 81. Just write it like this, and under this root symbol, find the prime factorization of 81. So 81 can be written as 3 times 3 times 3 times 3. Am I right? Right? 81 can be written as this, because so this is prime factorization of 81. 3 times 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. Now what you'll do, see, if you want to find out the cube root, so what you'll do, you look at the factors and you break the factors in groups of 3 numbers. So these 3 factors are appearing 3 times. So I can write it like this. See, 3 times 3 times 3 can be written as 3 raised to 3 times this 3 comes as it is. Okay. Now, if you remember a property that was done in grade 8, that property says that a times b raised to some exponent, let's say m, equals to a raised to n times b raised to m. So I'm going to just apply this property over here. First of all, I'm going to apply this property, compare it with this term. So this is 3 raised to 3 times 3 whole raised to the power 1 over 3. I applied this one. This is third root. So third root can be written as power 1 over 3. Now I'll apply this property. So this can be written as 3 raised to 3. Now this exponent will come to each of these terms. See this m exponent, this exponent m came to a as well as it came to b. So same thing will happen over here. This exponent will come on top of this term and on top of this term. So 3 raised to 3 raised to the power 1 over 3 times 3 raised to 1 over 3. Now, you remember power of a power rule? If we have a raised to m whole raised to n, so then the exponents get multiplied. So I'm going to apply this property here. So this becomes 3 raised to 3 times 1 over 3 times 3 raised to 1 over 3. So this 3 times 1 over 3 is just 1. So 3 raised to 1 times 3 raised to 1 over 3. So this is 3. And this can be written as cube root of 3. So this is your answer for cube root of 81. Simple. Yeah, it's very simple. You'll just require a lot of practice. Let's do one more question. Let's do one more question. Okay. Let's take color black. Let's see, you want to find out the value of negative 32 raised to exponent negative 0.4. So the very first step See, I would recommend pause the video and try to solve it by yourself. Whenever you see a negative exponent, this is negative exponent. Whenever you see a negative exponent, your first step should be to make the exponent positive. Make the exponent positive. And how do you make the exponent positive? By applying negative exponent rule. So if you have negative exponent, then we take reciprocal of the base and the exponent turns positive. So I'm going to take reciprocal of negative 32. So that becomes 1 over negative 32. And then the exponent becomes positive. That's your first step. Now your second step is going to be convert the exponent into fraction. Convert the exponent into fraction. So right now your exponent is in decimal. So you cannot evaluate its value. You cannot evaluate this expression when you have decimal exponent. So you need to convert it into fraction. Now 0.4 can be written as 4 over 10. And if you simplify it, you get 2 over 5. Okay, so this is nothing but 1 over negative 32. Instead of 0.4, I'm going to write 2 over 5. Okay, all right. Now, let's do one thing. Do the prime factorization of negative 32. Whenever you have a rational exponent, you'll do the prime factorization of this base. Okay, so can I write negative 32 as negative 2 times negative 2 times negative 2 times negative 2 times negative 2. This is going to be the prime factorization for negative 32. You can check it yourself. Do the prime factorization of negative 32. You'll get 5 negative 2's. Let's make it. And then I write 2 over 5. All right. Now, can I write it like this? Negative 2 raised to exponent 5 because you have 5 negative 2's. And this entire thing is already raised to 2 over 5. Then in the next step, I'm going to apply the property power of a power. A raised to m times a raised to m raised to n equals a raised to m times n. So the exponents get multiplied. So negative 2 raised to 5 times 2 over 5. And that is equal to negative 2 raised to 2, 5 and 5. So it's 5 times 2 is 10. 10 over 5 is nothing but 2. So that is 1 over. What is negative 2 raised to 2? It's 4. So this 1 over 4 is your answer for this term. So this topic covered numbers raised to negative rational exponents. Alrighty. Now I'm just gonna write some generic rules for your reference. Where is my cursor? Okay, here it is. All right, see guys, if you have any integer, it is raised to exponent m over n. So this can be written as a raised to 1 over n, complete thing raised to m. I'm just applying reverse of power rule. So see, a raised to 1 over m times m will be equal to a raised to m over n. So I've done just the reverse thing. Now this can be written as a raised to 1 over n will become nth root of a, and this complete thing raised to m. Okay. Also, you can do it like this as well. A raised to m over n equals a raised to m, and then you take its nth root. Okay, so a raised to m, and then you're taking its root. Now, some terminologies. This symbol is called radical. Okay, and if n is equal to 2, then this term is called square root. What do you call it? Square root. All right. And whatever is inside the symbol, that's called radicand. So this A is called radicand. So this was about introduction of rational exponents and radicals. I hope you understood the video and you understood the concept of radicals and rational exponents. Now in this video, we did how to simplify the expressions which have fractional powers, decimal powers, but the base was integer, right? Now in the next couple of videos, we'll do the same topic, but I'll take base as variables. So till then, take care. And if you haven't subscribed to my channel, Mathematics Stone, then please do subscribe. Remember, if you have this stone with you, if you have Mathematics Stone, then no topic of math can defeat you. Thank you. See you next time. Bye.